All right, so we're going to complete the square with the to write this quadratic expression in vertex form. Remember, completing the square is another way of solving quadratic equations. We began solving them by factoring, and we can't always factor. So when we can't factor, we can use a method like completing the square. All right, so the very first thing that we do is we group the ax squared term and the bx term. So we're going to write 3x squared plus 12x in parentheses, and then we're going to add the constant of plus 31 on the outside. The next thing that we're going to do is we're going to factor out the a term. The a term is 3. So 3x squared divided by 3 is x squared, and 12x divided by 3 is positive 4x. Remember, we have to take half of this term, this 4, and then square it. So what is half of 4? Half of 4 is 2. 2 squared gives us positive 4. So we've completed the square here for this perfect square trinomial there. And remember, we're going to keep our plus 31 on the outside. Now what we're going to do is multiply 3 times the 4 that we came up with to complete this square inside the grouping, so that we can subtract it from this constant so that we do not change the value of our equation. So 3 times 4 is 12, so we're going to subtract 12 from this constant. The next thing that we're now going to do is we're going to factor this perfect square trinomial. So we're going to have 3 times, we take the square root of the first term, so x squared gives us x when we find the square root. We take the sign of the middle term, which is a positive, and then we find the square root of 4, which is 2. So x plus 2 quantity squared, and now we are going to combine the like terms here, or the constants, positive 31 and negative 12. When we do that, we end up with positive 19. Here we have this quadratic equation written in vertex form. Now what we can do is we can solve this quadratic equation. If it's a function, we can solve to see if we can find some zeros. All right, so let's do that. We're actually going to set this equal to, well, if it's a function, we would write it as f of x, and I'm going to write it backwards this way because ultimately many of us like to see the expression on the right and setting it equal to 0, on the left, and setting it equal to 0 on the right. All right, so now what we're going to do is we're going to get rid of this constant. To get rid of the constant, we're going to subtract 19 from both sides. When we subtract 19 from both sides, we're left with 3 times x plus 2 quantity squared equals negative 19. Now we're going to get rid of this 3 times that quantity squared. So the it's being multiplied. So the opposite of multiplying by 3 is to divide by 3. 3 divided by 3 gives us 1. So we're left with x plus 2 quantity squared is equal to negative 19 divided by 3. When we divide that, we end up with negative 6.33333. So we're going to put a repeat bar over the 3. As we recall from previously, the next step is to do the opposite of squaring, which is to find the square root. Here, square root and squaring cancel out, so we write x plus 2. But wait a minute. This says a negative under the square root. Let's think about what this means, the square root of 25. It means 5 because 5 squared, or 5 times itself, gives you 25. Is there ever a case where you can multiply a number by itself? So like 5 times 5 is 25. Even negative 5. Negative 5 squared is the same as negative 5 times negative 5, which still gives you positive 25. So this answer is actually plus or minus 5, because positive 5 squared is 25, negative 5 squared is 25. So we will never, if we're squaring a number, get a negative as our answer. So we are actually finished here, and this has no solution. All right, this has no solution because we cannot find the square root of a negative number. Of a negative. So again, the answer here is no solution.